Hey, how you doing? This is Mel Strong, and this lecture is on how to identify and name clouds. Now, we're not going to talk about the processes that actually form the clouds. That will be in a future lecture. But here what we're doing is we're learning a naming system that was developed by Luke Howard a couple hundred years ago. Luke Howard was a pharmacist, and he just really liked clouds, and he painted paintings of clouds. And then in 1802, he published a classification system, because up to that point there wasn't one. And his classification system isn't perfect, but it's still in use today, and his cloud names are still in use today. So that's what we're going to learn. And in his system, you need to know two things to name a cloud. You need to know the cloud's shape, and you need to know the cloud's height above the ground. Now, as far as shape goes, all clouds in this system have to fall into one of three possible shapes: Cumuloform, Stratoform, and Cirroform. And I'll show you examples of these shapes in a minute. And then for height, we just have three categories of heights: low, middle, and high. And with those three shapes and those three heights, we come up with 10 different cloud names in this system. So first we're going to go through the shapes. And cumuloform shape clouds are also known as heap clouds. These are the clouds that are kind of puffy looking, or they might kind of look like cotton or cauliflower. And they might be wider than they are tall. They might be taller than they are wide. They might be just little tiny puffballs. They may be low, droopy clouds. But all of these have something in common, which is they all have this kind of puffy edge on them, right? So these are all cumuloform clouds. Now, the stratiform clouds are a lot more boring, and they're sometimes called the layered clouds. They're like these big blankets that cover the sky. And so you don't usually see a lot of features within these clouds. Maybe you can see the sun poking through, maybe not. But just think of like a big solid gray sky, and that's a stratiform cloud. You usually can't see the edges of these. Then cirroform are the clouds that are kind of wispy or curly or hairy. Sometimes they'll have little hooks on the end, sometimes not. Here's some that have little heads with little feathery trails leading off of them. These are pretty straight. So there's a lot of varieties in cirroform clouds. Now, we've talked about the three shapes. Let's talk about the three heights. And in order to understand this low, middle, high terminology, we have to explain a little bit how the atmosphere is structured. And so let's imagine that we've got a mountain range here, and we were, let's say, to launch a balloon up into the air above this mountain range. And on the balloon, we put a temperature sensor so it could tell us what the temperature is, which is what a weather balloon actually does. And so if we had a balloon and we let it launch and we collected all this data as it climbs up into the atmosphere, and then we took all that data, let's just say it's collecting temperature data, and we made a plot, right? And in my plot, I've got an x-axis of temperature, so it's warmer to the right, colder to the left, and I plot height on the y-axis, and I were to plot that data that balloon measured, my graph would look kind of like this at first. The balloon would notice it's warmest near the surface, and as it goes up into the atmosphere, it cools and cools with height. And that probably makes sense to you, because if you go up to the top of a mountain, it's usually colder up there. We'll learn in a later lecture that when the sunlight passes through the atmosphere, it really doesn't interact with it. It warms the ground, and the ground warms the atmosphere from the bottom. But for now, all we have to realize is that this trend happens, and then at some point, something weird happens. Our little weather balloon would notice that the air actually starts warming up when it gets to a certain point, and continues to warm up as you go higher. Okay. Now, in a later lecture, we'll explain more about why this happens. But for now, all we're going to say is that this little inflection point between where the atmosphere cools with height and when it starts to warm with height, that forms a natural boundary between two layers in the atmosphere, and all the air below that line is called the troposphere, and all air above that line is called the stratosphere. So the reason we're talking about this is this low, middle, high business. That refers to low, middle, high in this layer, in the bottom layer of the atmosphere. Now, the exact height of this varies by season. It can vary by day. If it's a really cold day, it will be lower. If it's a hot day, it'll be higher. If you're in the tropics, it's higher. If you're near the poles, it's lower. But kind of a worldwide average is close to 7 miles above the ground is where this division is. So our low, middle, high clouds have to fall somewhere between close to the ground level and up to as high as maybe 7 miles. So roughly, we just divide it like this: low clouds, middle clouds, high clouds. Now, there's a problem with this in that we don't have a word for a cloud that's in here or a cloud that's in here. So we kind of have to force clouds to fall into one of these three categories. So like I said, it's not necessarily a perfect system. So the high and mid clouds have a prefix. So if a cloud is up here, we give it a prefix cirro. And if a cloud is kind of around here, we give it a prefix alto. And if a cloud is down here, it does not have a prefix. This will make more sense when I give you some examples. Okay, so let's start with one. I have a cumuloform cloud and it's low. I call it cumulus. All right. Now I take that puffy cloud and I move it up to kind of the middle of the troposphere. I would call that altocumulus. It'll look smaller, and I'll show you pictures of these in a second, but that alto tells you the mid-level of the atmosphere or troposphere. If I move that puffy cloud up higher, it'll again appear even smaller, and it'll have that prefix cirro. You can do the same thing with stratus clouds. It works a little bit differently. So here's a high stratus cloud, a blanket. That would be cirrostratus. With altostratus, usually what that means is that that high cloud extends all the way down to the middle of the atmosphere, middle of the troposphere. That's altostratus. And if it extends down almost to the ground, doesn't have to touch it, but gets low, we'll call that stratus. So again, there's no prefix here. So what we're going to do is we're going to go through some pictures of some of these clouds, and we're going to learn the cloud names, and we're going to learn how to identify them. So first we're going to start with cumulus, and cumulus are probably the most commonly known cloud. These are the clouds that you see on a summer day a lot of times here in New Mexico, and if you watch this for a while, you'll see the clouds will grow and they'll die and they kind of drift around, but they're not getting too terribly large. Now these are considered low clouds, and this is one of the things you kind of have to get used to, is recognizing what we call a low cloud and what we call a middle cloud and a high cloud. So everything I'm showing you here are low clouds. If you ever lay on your back and you're looking up at shapes changing in the clouds, you're probably looking at cumulus clouds. Sometimes, especially here in New Mexico in the summer, they'll have flat bottoms. That's not always the case, but that's a common feature that they have. So depending on when you look, they may have different proportions. So right here, that one's wider than it is tall. But as I sit here and watch this grow, now it's the same height as it is wide. And then as I wait, I can see now it's getting taller than it is wide. And later, in a later lecture, we will talk all about what's happening here and like why this cloud is growing. But the point is, the proportions can be totally different just depending on when you're looking. So, this cloud is clearly getting pretty tall. It started out, wider than it was tall, but it's changing that as the day progresses. So here's some, for example, they're just about as tall as they are wide. Notice that these are also have mostly flat bottoms here. Here's one that's taller than it is wide. So here's a typical summer day in New Mexico. We've got a bunch of little cumulus clouds here. And if you watch them for a while, you'll see one being born, and then you watch it, and pretty soon it will die and dissipate. And they just continue to be born, live for a while, and die as the day continues. So these are all cumulus. Most importantly, when the opening credits of The Simpsons occurs, the clouds that they show are cumulus clouds. And in fact, in the city where they live, cumulus clouds are the only clouds they ever have in that show. So now let's move up to altocumulus clouds. So now these are going to be higher above the ground, so naturally they're going to appear smaller because they're farther away from us. But the clouds themselves are actually also smaller. And here's some typical altocumulus. So these are considered mid clouds. So now these are not low. and these are considerably further up in the atmosphere. You can see how they're smaller. And often they will kind of form a patchwork pattern. Cumulus clouds are more kind of randomly spaced. Altocumulus often form these patterns, kind of like what we're seeing here, like a patchwork again. Sometimes they'll be touching each other, sometimes they won't be touching each other. Another example. So everything we're seeing here is a mid-level cloud, and so nothing here is considered low level. So again, this is what takes some practice to get used to. Here they're all touching, and these clouds are a little bit lower than the previous slides, but these are still considered altocumulus clouds. And here you can't even see the sky, so that is a possibility that they could form a continuous blanket of cloud. Okay, so that's altocumulus. They don't necessarily have to be independent little puffballs. A lot of times they'll align themselves in rows, and we call this undulatus, but all you need to know here is that these are actually aligned rows of altocumulus clouds. So still puffy clouds, still mid-level in the troposphere. All right, let's go on to cirrocumulus. And because they're so high up, these are little tiny puffy clouds that you can actually kind of see through, right? Like light will shine through cirrocumulus clouds because they're so thin. And you know, they're tiny because they're far away, but they're also literally very thin clouds. And cirrocumulus clouds often form patterns in a similar way that the altocumulus form patterns. So sometimes there'll be this patchwork. A lot of times they'll often also form in these rows, kind of like this and this. So again, that's that undulatus texture that I alluded to earlier. So these are, again, upper part of the atmosphere. So here's some rows you can see there a little bit. Okay, so cirrocumulus. Now, this brings up an issue, which is how can you tell the difference between cirrocumulus and altocumulus? Because they're both puffy and they're both kind of small. Now these are super tiny little dots, right? So if you saw super tiny little dots, you're pretty easily in cirrocumulus. But if you have bigger ones, how can you tell them apart? They might kind of be the same size. And so one way to think about this is think about it like you're a painter and you're going to paint these two images of clouds. So notice the one on the left. This is our altocumulus. It has more shading. It's more three-dimensional. The cirrocumulus is more two-dimensional in appearance. They're so high up there that you can hardly see any shading. Now, this doesn't work 100% of the time, especially if it's sunrise, sunset, and you have a low sun angle. A lot of times you'll get shading even on cirrocumulus. But if you're one of my students and you have to identify which one of these clouds you have, go with the shading. If you see shading, you know it's altocumulus. If I give you one that does not have shading and just looks two-dimensional, go with cirrocumulus. So there's a fourth puffy cloud that actually does not exist at just one of these three levels, but in fact can exist at all of those three levels at the same time. It starts out low and it grows up high, and that's called the cumulonimbus. Now, a cumulonimbus also has another more popular name, which is thunderstorm, because this nimbus means precipitation. So anytime you have a puffy cloud that is precipitating, whether it be rain or snow, you go with cumulonimbus, even if it's not making any audible thunder or you can see any visible lightning. Just the fact that you have precipitation out of a cumuloform cloud, we're going with cumulonimbus. So here's an example of what is first a cumulus cloud right now, but then notice right there we're starting to get some precipitation. And in a later lecture we'll explain why this is happening, but for now just realize that a cumulus can sometimes turn into a cumulonimbus if the conditions are right. So once you see precipitation, you have to go with a cumulonimbus. Now, here's a classic cumulonimbus, and you can see that at the top of this, you are getting there's a kind of a fuzzy appearance on the top of this cloud, and that's called the anvil. And the anvil is made of ice, and in fact, you'll notice that this part of the cloud has a very sharp boundary between the puffy part and the air, and this part is very fuzzy. This is how you can tell the difference between ice and liquid. So you can have clouds that have little microscopic liquid droplets, and you can have clouds that have little microscopic particles of ice. And the difference is that the ice will look fuzzy, and the boundary of a liquid cloud will be very sharp and distinct. So here we've got one forming over the sandias. That's the anvil, and that's all ice. Now, we can't really see here whether it's raining down there, but if you see the anvil, you're pretty much guaranteed that it's raining or perhaps even snowing. So when you see the anvil, think cumulonimbus, because there's no other cloud that forms that kind of structure. So here's some anvils forming in the distance. So they're so far away we can't tell if there's rain or not. But when I see that anvil is growing there, and this one's starting to form one, and it will grow. These cumulonimbus start out without an anvil, but as time goes on, the anvil will grow, and as the storm becomes more mature. But if you look out in the distance and you see that anvil, you know they're having a thunderstorm, and then you know there's precipitation. So anvils are always going to be cumulonimbus in this class for sure. If you can actually see precipitation, you also know you've got cumulonimbus. So here, we've got a thunderstorm over the sandias. You can clearly see the beginning and the end of where the rain is falling. If you can see definite boundaries with the rain, you've got cumulonimbus. So in this example, we can't see the anvil. We can't see the top of the cloud. We can see some flashes of lightning there. But normally, especially like New Mexico summer, this is kind of a typical cumulonimbus. You can see the puffy cloud above. You can see a shaft of rain below. You know you've got cumulonimbus. But if you can't see this up here and all you get to see is this down here, if you can see a boundary where the rain ends somewhere, you've got cumulonimbus. Okay? So here's a classic example. Cumulonimbus over Albuquerque. That rain coming down, even though I can't see anything above here, I don't know if it's got an anvil or anything, the fact that I can see that the beginning and the end of this rain column tells me it's cumulonimbus. Now, in the winter, sometimes we can get cumulonimbus, and because it's so cold, the entire cloud is made of ice crystals, and you can see that it's fuzzy up here, but it's even fuzzy down there. And this is a cumulonimbus that's snowing. Okay, so if you see that, it still has this anvil shape, but it's snowing all the way down to the ground. There's another type of puffy cloud that's kind of a special case. It's called stratocumulus. So if I have one low puffy cloud, I've got cumulus. If I have two low puffy clouds, I would still call them cumulus. But if I have so many puffy clouds that they end up touching each other or almost touching each other, and maybe I can see a little light in between, I'm going to go with stratocumulus. Stratocumulus is actually the most common cloud type on Earth, but we don't see it that much on land because stratocumulus occurs over the ocean. And we get it once in a while here in New Mexico. So here's some stratocumulus. So if I could just pull out one of those blobs, I'd have one single low cumulus cloud. But I have so many of them that I can see some light in between, and maybe I'll get a glimpse of the sky or maybe not. I'm going to call this stratocumulus. So classic stratocumulus, they look very, they're very low, they look very heavy, very bulbous on the bottom usually. Typically, worldwide, you don't see so much flat bottoms on the stratocumulus like you do on your cumulus clouds. Over time, they just kind of have those, they roll and very slowly change their shapes. But again, you can see the breaks in between, can't really see the sky here. So that's stratocumulus. I took this from a plane looking down. This is what stratocumulus looks like from above. And if you were to fly over the oceans, sometimes you will see this for just thousands of miles. And this is just, like I said, this is the most common cloud type on Earth, the stratocumulus. It tends to form over the oceans. Now, it might be confused with this one. This is one we just saw. This is the Altocumulus. And the Altocumulus kind of looks like the stratocumulus, but these are higher up in the atmosphere. And the stratocumulus are low only. So keep in mind, this is a mid cloud, whereas this is a low cloud. See, you can see it brushing the top of the Sandias there, kind of in the distance there. So that's kind of how you tell these two things apart. Is it if it's low and it's just solid puffy clouds, stratocumulus. If it's mid-level, altocumulus. So we've gone through all the cumuloform clouds, and now we're going to go through the stratoform clouds, which are a lot less interesting to look at. We're going to start with stratus, which is a low stratoform cloud. And the key to identifying stratus is that you cannot tell where the sun is. So it's a gray sky, and in this time lapse, the sun is actually right there, but you can't see it. So if you've got a gray sky and you can't point to the sun, then you've got stratus. Okay, so might be light gray, might be dark gray. There might be some texture in the sky, there might not be, but what's consistent is that you can't tell where the sun is. Now, if that gray sky is also producing precipitation, either rain or snow, we're going to call it Nimbostratus. There's only two types of clouds that produce precipitation. Cumulonimbus, which is the puffy one, and Nimbostratus, which is the layered one. And Nimbostratus, gray sky as far as the eye can see, producing precipitation as far as the eye can see, right? So with cumulonimbus, you could tell where the boundaries of the precipitation were, or at least one of the boundaries. With Nimbostratus, you can't tell where the storm ends because it just, from your perspective, looks like it's going on forever in all directions, okay? And again, it can be rain or it can be snow. That's Nimbostratus. Okay, now, if our cloud deck is thinner and we get up to the middle part of the atmosphere, we call that altostratus. And because it's thinner cloud, the sun will kind of poke through, except it will be a fuzzy ball. So here is some altostratus, and you can see we can point to where the sun is, but it's a fuzzy ball, right? So that's your key for altostratus. Clear, gray sky, but you can identify where the sun is in each case, right? So altostratus. So when we get to the top of the troposphere, we have a very thin layer of cloud that we call cirrostratus. And not only is this cloud very thin, but because it's so high up, it's actually very cold and it's entirely made of ice crystals. And it turns out that when light shines through a layer of ice crystals, it makes an optical pattern. It makes a circle. And cirrostratus clouds are characterized by this ring that goes around the sun. Now, the pictures I'm showing you here are not mine. I have a really hard time getting good pictures of cirrostratus clouds, and some of these I've been able to track down the source. Some of these are they're all over the internet, and I can't figure out where they originated from, so I can't give everybody credit. But key is that in a cirrostratus cloud, you might see the sun as a fuzzy ball, but the key is look for this ring. And that ring will sometimes have little rainbow colors in it. So this is probably the best one I have, where you can kind of see some color in there. Not only do you get a ring around the sun, but you can get a ring around the moon. And this kind of shows you how thin this cloud is. Like, you can see stars through it, right? So it's even hard to call it a cloud, but we do. It's just this very thin layer of ice crystals way at the top of the tropopause. Okay, so cirrostratus, you're looking for the ring. Okay, so we've gone through cumuloform, we've gone through stratoform. Now we're to cirroform, and with cirroform clouds, there's actually only one type. There are no low clouds, there are no middle clouds, there are only high cloud versions of cirroform. And so those are called cirrus. And because they're so high up in the sky, they're entirely ice. And they have kind of, there's a wide variety of textures for cirrus clouds. Typically, they're very, kind of wispy, hairy, feathery looking. So these kind of look like cobwebs. Sometimes they cross each other and it look like they're kind of tangled up, like these. Here's some that look more feathery, and these kind of have a net-like appearance. Sometimes they'll get so dense that it'll appear solid gray. And some people might try to call this cirrostratus, but if you're one of my students, if you can see the edge of something like this, still go with cirrus. A lot of times they'll be hooked, so you can see some of these have little hooks on them, and occasionally they'll be just perfectly straight. So here are some perfectly linear cirrus clouds. Here's some of those hooks. Here's some that have this generating head with a little tail on it. Okay, here's some that crisscross each other. So there's all kinds of shapes of cirrus clouds, but they're pretty easy to identify. They don't look like anything else that we've seen here. So those are the 10 cloud types as originally outlined by Luke Howard back in 1802. And most of the clouds you will ever see will fit in one of those categories, but there are a few oddballs that don't completely fit. And I'm going to give you two more. And these two you actually will see in New Mexico occasionally. So for the first one, here we've got the sandias, and there is wind that's blowing up over the sandias. And for reasons that we'll explain in a later lecture, when air rises, it can form clouds. So there's this little cap of a cloud that sits on the mountain. Okay, now that cap is now grown, and it's starting to get this shape that's kind of a disc shaped. And we call these clouds lenticular clouds. Or if I zoom out a little bit more, okay, so this whole thing now is this air mass moving over the mountain is creating this disc called a lenticular cloud. But sometimes the air, when it moves over the mountain, the cloud isn't actually touching the mountain. So for example, here we've got air moving over the mountain, and it's creating lenticular clouds that are hovering above the mountain, but it's still the same process. Here are some more. Okay, so these are all lenticular clouds, these disc shapes, and there's air moving over the mountain. Here, sometimes they occur in stacks. So these are low clouds. Those are cumulus down there. Lenticular can be, usually they're low to mid clouds. These are fairly low, but they're higher than the cumulus in this one. And often you will see chains of lenticular clouds. So sometimes you'll get isolated little disks, and sometimes you get a whole bunch of them kind of all together. And you can see in this how there's air moving in and out of these lenticular clouds. So there's a big kind of wave here in the atmosphere that's causing this. And the wave is very slowly moving from left to right in this time lapse. Here's something similar. So we've got a wave in the atmosphere, and these lenticular clouds are riding the top of that wave, and the wave is very slowly moving from left to right. So one thing that can happen with lenticular clouds is, let's say we've got a mountain range and we've got wind coming out of in this case, let's say this is the Sandias, and wind would be coming out of the west, and air is going to be forced up the mountain. Now, we'll learn in a later lecture that if you take air and you push it up, eventually it will reach its dew point and form a cloud. And so that's going to happen here, and we're going to get this little lenticular cloud that forms on the top of the mountain. Okay, now the air goes down the other side of the mountain, but the thing is, air is compressible and it's bouncy. So if you compress air, it kind of bounces back. So what happens is, as the air comes down the mountain, it'll actually bounce in the atmosphere, and you can't see this, but there will be these big waves that form in the atmosphere. And at the top of each wave, if the wave goes high enough, it will make another lenticular cloud. So often, you don't just get one, you often get a whole chain of lenticular clouds. So that's what's happening here. This is Mount Shasta. There's a lenticular hat kind of on the top, and we also see some lenticular clouds nearby. And they're all related, that we're making waves in the atmosphere from that mountain interacting with the wind. So here, a whole chain of lenticular clouds. Again, I've got images here that I can't track down in terms of the original source, but they're very popular on the internet. So that's what you're going to see here on some of these. But here's a whole chain of them. So the atmosphere is, again, kind of bouncing, and as it bounces, it makes lenticular clouds at the top of each of those waves. Sometimes they'll occur in stacks. Okay, that can happen. And in fact, here's a image from National Geographic. This is, I believe, is Mount Rainier, and these are, you know, big stack of lenticular clouds on top. Here's one I took over campus. You don't have to have a mountain to get lenticular clouds. Conditions are right, you can get lenticular clouds just about anywhere, but mountains definitely help their formation. Would it surprise you if I told you that every year there are an alarming number of 911 calls that are made because people are reporting UFOs when they see clouds like this? Maybe that doesn't shock you, but you know, that's kind of convincing, right? Or how about that one? I mean, that's the mothership showing up for sure. So some of them really do look like UFOs. And here's another one from National Geographic, and they took this picture right before the zebra got abducted here. Okay, so that's lenticular clouds. That's an extra one. Another extra one, here's a cumulonimbus, so that, remember, that's the thunderstorm. And sometimes what we'll get right on the bottom of a cumulonimbus are these sinking blobs of cold air that come down. And they form kind of a droopy looking cloud that's called mammatus. And these will often happen right before or right after a thunderstorm occurs. So here they are. Each one of those blobs is sinking cold air that's coming down out of this cumulonimbus. Here's some more that are, these are better lit here. So you can see them starting to come down. We got a little precipitation over here, but for the most part, those are just blobs of cold air. Here's some good ones forming right there. Okay, so these are all mammatus, these blobs coming down. So again, sometimes you'll see this right before a thunderstorm, or sometimes you'll see it right after a thunderstorm. So we do see these in New Mexico in the summer. Now there's a thunderstorm in the distance, and this is the anvil that's kind of drifting over us. And sometimes they'll form in the anvil itself, so you can see some little blobs in there. And sometimes you'll see really spectacular photos of mammatus. In New Mexico, the best time to see mammatus is late in the afternoon. When the sun angle is low, they'll show up better, kind of like this one or this one. These are mammatus forming in an anvil. So this whole thing up here is the anvil. And another one, again, near sunset, and it really exaggerates the mammatus, makes it easier to see. A lot of times, the mammatus that we get here in New Mexico are not nearly as good as these pictures I'm showing. So this is probably the best mammatus that I've taken a picture of here in Albuquerque, but this is kind of more typical. So this is on campus, and you can see that there's blobs in there, right? But it doesn't look nearly as well defined as some of those other pictures. Okay, so in conclusion, we got 10 cloud types that were originally defined by Luke Howard back in 1802, and on top of that, I'm giving you 2 others that don't fit very well in that original classification system, lenticular and mammatus. Okay, so in the next lecture, we're going to start getting into humidity, and we're going to work up to how these clouds actually form. Thanks for watching.